Hi everybody, welcome to a brand new lecture of the Ankit Faria Certified Ethical Hacker course. This is going to be a continuation, in fact the third lecture related to network reconnaissance and information gathering. In the previous two lectures, we had discussed a wide variety of different information gathering techniques, starting with ping, traceroute, how to guess the OS using ping and traceroute, DNS tools, and then moving on to port scanning, daemon banner grabbing, and a little bit of OS fingerprinting. So in the previous class, we had just started discussing OS fingerprinting when we ran out of time. So don't worry, I will actually restart from the beginning of OS fingerprinting and give you a live demonstration all over again today. Information gathering, like I had mentioned in the previous two lectures, is an extremely important step that every hacker must take if he wants to successfully be able to hack into the victim's computer. Now, information gathering, the good news is that it's all automated. In other words, you have ready-to-use software like Nmap, which essentially does everything from ping till OS fingerprinting for you. And once you perform information gathering and network reconnaissance accurately and successfully, then using the information that you have found out about the victim's computer, maybe the victim has an open port that is running a vulnerable software, you can then search online for the vulnerabilities that affect that particular software. And today we'll also see, once you have identified a particular vulnerability on a remote computer's open port, how do you actually exploit that vulnerability? How do you attack that vulnerability? How do you attack that particular port? So it's going to be a very interesting lecture. So let's go ahead and switch to my PowerPoint slides, and I'd like to go ahead and start with today's lecture. So let me start at the beginning of OS detection. Now OS detection, let me quickly recap it. It's basically a technique that allows a criminal to determine the operating system that is running on a remote computer. Without knowing which operating system is running on a remote computer, it is extremely difficult for you as a criminal to actually successfully manage to hack into the victim's computer. Because say for example, if there's a particular vulnerability that affects Linux computers, it will not affect Windows computers and vice versa. So whenever you're doing information gathering on the victim's computer, not only are you trying to find out what are the open ports and the software running on those open ports, you're also trying to find out the OS running on the remote computer. Because the vulnerability that you find, or the vulnerability that you end up using to hack into the victim's computer, it may either exist in the operating system of the victim, or it may exist on one of the software that are running on the open ports on the victim's computer. So the vulnerabilities that you can use to hack into the victim's computer can exist at either of these two places. So keep that in mind when you're performing information gathering. Now, like we had discussed in the previous lecture, OS fingerprinting, there are actually two different types of techniques. One is active fingerprinting, and the second is passive fingerprinting. The main difference is that in active fingerprinting, your identity gets revealed to the victim's computer. And in passive fingerprinting, your identity is actually protected and it does not get revealed to the victim's computer. Let me actually explain this through a small diagram which I like to draw in this notepad file. Now typically in active fingerprinting, what happens is that attacker, so let me just call the attacker you. So you send some probing packets to the victim, right? In the second step, the victim will send back some replies to you. And then you analyze the replies specifically. You look at various fields like TTL values, DF bit, etc. And then you estimate the OS running on remote computer. So that is essentially what active fingerprinting is. You as a criminal have to send some data packets to the victim. It could be any kind of data packets, and then the victim will send back a reply to you. You analyze the replies just the way in the ping and trace route OS detection technique that we have discussed earlier. You basically ping and trace route the victim. You get a response from the victim. You analyze the response and analyze various fields like TTL values, DF bit, and so on. And then you figure out what is the operating system running on the remote computer. Because every operating system has some default values that they use in various fields of data packets that they create. So a Unix computer may create data packets with a certain type of fields. So the TTL value of a Unix computer will be different from the TTL value of that of a Windows computer. So that is essentially what happens in active fingerprinting. And how do you perform active fingerprinting? Once again, you can use Nmap or you can use Zenmap. The problem with active fingerprinting is actually the first step, which is you as a criminal have to send some kind of probing packets to a victim. Now these probing packets can be blocked and also can be used to identify the criminal. So the victim may detect that you're sending some kind of OS detection kind of packet, so they will actually detect that, hey, you're a criminal and you're not a regular user. So the identity of the criminal gets revealed in active fingerprinting, which is where passive fingerprinting comes into the picture. In passive fingerprinting, everything remains the same except step number 1. So in passive fingerprinting, what you need to do is you basically open your browser and connect to website of the victim. That's it. And the victim will then send back website to you. Send web page to you. So that's all that happens in passive fingerprinting. Now, it's a very small difference. So in active fingerprinting, you send probing packets to the victim's computer. But in passive fingerprinting, you do not send any probing packets. Instead, you maybe just open your browser and visit the website of the victim. Now, the difference is, if you just visit the website of the victim, there is no way for the victim to differentiate whether you are a criminal or whether you are a regular user. So the victim has no clue whether you are a regular user or whether you are a criminal. As a result, your identity is protected. Now, when you request for a web page from a victim, the victim will send back the web page to you. Along with that, there will be some TCP packets that the victim will send to you. Those TCP packets you then analyze. Again, you analyze the various fields or the values of the various fields like TTL values and so on. And then you try to guess or estimate the operating system running on the remote computer. Because different operating systems have different initial values of the various packets. So default values that they use in various fields of the data packets are different in various operating systems. Now for passive fingerprinting, you can't use Nmap or Zenmap. There's another software called POF. P0F. And network miner. So POF and network miner are tools that allow you to perform passive fingerprinting. So now that you understand the theory, let us actually see a couple of demonstrations of OS detection. So different operating systems have different stacks or different kernels. Hence, different operating systems will respond differently to the same data packet that is sent to it by the criminal. This difference in responses is used as a benchmark or a technique of differentiating between the various operating systems. For example, the response sent by a Windows system to a data packet will be different from the response sent by a Unix computer. So the typical working we have already kind of seen. Depending on the response that you get from the victim, You basically analyze the response and you can identify or guess the operating system that is running on that remote computer. So in active OS fingerprinting, you need to actively send some data packets to the target system or the victim's computer to generate a response. And once you receive a response from the victim, you then analyze the response and compare it with the list of known responses to determine the operating system running on the victim's computer. Typically, while you're analyzing the responses that you receive, you analyze the various fields of the TCP packet. If you remember, when we had discussed port scanning, I had shown you what a TCP data packet header looks like. It has various fields in it. So you analyze those fields like TCP initial window size, TTL value, ACK value, initial sequence number, handling of overlapping fragments, and so on. The problem with active fingerprinting is that since you are actively sending probing data packets to the victim, your identity may actually get revealed to the victim. Hence, it is not 100% anonymous. The command that you got to type in Nmap to perform active fingerprinting is the following. You type nmap -o or -a followed by -v followed by the victim IP address or the victim website address. So let us now see a demonstration of OS fingerprinting, specifically active fingerprinting using Nmap. Yes, in the previous class I had tried to give you this demonstration, but we couldn't complete the demonstration. So I'm going to quickly repeat this demonstration for all of you. So let me open up Nmap or ZenMap on my computer. It will take a minute for it to open up. Let me try this again. Okay, Nmap has finally actually opened on my computer. So the command that you got to type is nmap-o or -a followed by -v followed by the victim address. So I'm going to go ahead and type the command in this space provided. The victim, I'm going to type imt.edu. So OS detection will usually take the longest amount of time compared to any other Nmap command that you're going to type. So let's wait for the results to show up. While the results are showing up, I'm going to open up an older version of Nmap which I usually like to use. So just give me a minute. In the background, the OS detection or OS fingerprinting is taking place. I generally prefer this older version of ZenMap. I found the results to be much better as compared to the new version. But you can choose to use whichever version you feel like using. So as you can see, it does take some time. So I'm going to go ahead and run the second OS detection command. So in the new version of Nmap, we have used the -o argument. I'm going to now use -a argument in the old version of Nmap. It really doesn't matter. Both are pretty much the same commands, they'll pretty much give you a similar response. So as you can see, Nmap takes a very long time in Windows to figure out the operating system running on the victim's computer. So what I like to do today is, I like to actually, for the first time in this course, introduce all of you to Backtrack, which is the Linux operating system. And I purposely showed you this Nmap demo in Windows, and then I like to show it to you in Linux. And you will see that from a speed perspective, from a output perspective, from a detailing perspective, Nmap in Backtrack is much better than Nmap in Windows. So we'll probably see that later today. I'm going to go ahead and close the new version of Nmap. In the meantime, let's look at the old version of Nmap that I was running. So right now it is, first of all, it performs a port scan. So as you can see, the old version of Nmap is much faster than the new version, which is why I prefer it. So it is performing port scanning on 1,000 different ports on imt.edu. It says completed the SYN's stealth scan, which is the half-open scan, port scan that we have learned about in the previous lecture. And now is performing a service scan, which essentially means daemon banner grabbing. So when you perform OS detection on a remote computer, it starts with a simple ping, then it performs port scanning, then it performs daemon banner grabbing, and eventually it performs OS detection. And also, if you notice, it's performed a traceroute as well. And it's using traceroute to try and figure out the operating system running on the remote computer. So a typical OS fingerprinting scan can take between 3-4 minutes, because it keeps trying various different techniques until it can collect adequate information to be able to successfully guess the operating system running on the remote computer. So if all of you look at the screen, we have finally completed the scan. So let me actually take all of you through the scan, and since the font size is slightly small on the screen, I will try to just copy everything into a notepad file and then show you and discuss the results. Okay, so if all of you look at the screen, this is the output that we got. So it's saying that, okay, starting Nmap, it then loaded 57 scripts for scanning. It started with a ping scan. It is trying to see whether it is whether the victim is online or offline. Then it initiated a port scan on the 1,000 different ports that are there on imt.edu. It has then listed all the different ports that it found to be open on the victim's computer. So these are all the different ports that are open on the victim's computer. Then it started a daemon banner grabbing scan, and it started traceroute to try and find out the operating system running on the victim's computer. So if you notice, now it has displayed all the different open ports and the respective software running on those open ports. So Microsoft FTPD is running on port 21. Mail Enable SMTPD 7.07 is running on port 25, and Microsoft IIS is running on port 80. So similarly, it has shown us a lot of different ports. The SQL server that they're running is Microsoft SQL Server 2008, and another port they're running MySQL Server 5.1.68. So these are all the different ports that are open, and also the various software running on the open ports. Let me just delete this and then move on to the OS detection part of the output. So if all of you look at the screen, so based on the output, the imt.edu website is running Microsoft Windows Vista, so and so version, and it also tells you, how confident it is about the result that it has shown you, and then eventually at the bottom it is showing you the trace route that it did to the victim. So that is what a typical OS fingerprinting scan result looks like. So in a matter of a few minutes, we were able to figure out that imt.edu is running Microsoft Windows, I believe Vista. So the new version of Nmap, for some reason on my computer I've always had some problem with it. So I use a slightly older version of Nmap, which is version 5.51, and it works perfectly for me. So you may or may not face the same problem. I don't know why this problem exists on my laptop. Maybe I should try another computer. But just so that you know, sometimes even the latest version may not for some reason work. So you can always download an older version of Nmap. From the Nmap website, they give you an option to choose whichever version you would like to download. If not from the Nmap website, you can do a Google search and use any other popular file sharing website to download any version of Nmap that you may please. So that's typically what active fingerprinting is all about. It takes 2-3 minutes, but then eventually it will show you the exact operating system running on the remote computer. Now the problem with active fingerprinting is that your identity gets revealed. So the victim will know who you are. The victim will know that you're performing some kind of scan and you're up to some kind of mischief. Which is why passive fingerprinting is so important. Passive fingerprinting, let me warn you, does not always work. So obviously, while passive fingerprinting is much better in the sense that your identity is hidden, but at the same time, it may not have the success rate that active fingerprinting does. So the problem with active fingerprinting is that it reveals your identity to the victim, where passive fingerprinting is different. So it does not actually reveal your identity to the victim. And one of the best passive fingerprinting tools available on the internet is POF, P0F, and it is available as a free download on the internet. In active fingerprinting, the OS detection tool will actively send probe packets or queries to the victim. This reveals the attacker's identity to the victim. In passive fingerprinting, you don't send any packets to the victim. Instead, you maybe just open your browser and connect to the website of that particular victim, and the passive fingerprinting tool will just record the response that you've received from the victim and then analyze the response, analyze the various fields of the data packets of the response to then try and find out what is the operating system running on the victim's computer. And the type of fields that it analyzes are pretty much the same, like TTL values, window size, DF bit, type of service, and so on. As simple as that. Now, along with POF, that is P0F, you have network miner, which is another very interesting or very useful passive fingerprinting tool. So at this point of time, let me actually give you a demonstration of both POF and network miner. Now POF runs out of the MS-DOS prompt. So I'm going to open up POF. Make sure that you go to the directory or the folder where you have installed POF. If you're using POF for the very first time, you can type POF-H and that will display the help file. Since you can't really see the screen very clearly, let me type the commands into Notepad as well, and all of you can copy the commands down. So the first command that you gotta type is help, that is P0F space -H. The next command that you gotta type is P0F-L. It will list all the internet connections that are available on your computer. So let me type that command. So if you notice, it has listed all the different connections that exist on my computer, and the first column on each row there's a number, and that number reveals, so that's just a number of that respective internet connection that exists on your computer. So right now I'm connected using the Ethernet port, which is the number 3 connection. So I need to make a note of it. So make note of internet connection. I'm saying internet connection, but actually it means interface or NIC card. So make a note of the internet connection. So for me it's number 3. So the next command is POF-I3. Is basically telling the POF software to start monitoring all data being sent or received on interface number 3. So I type that command. I hope that is the right command. I think it is. Yeah. So for some reason, the first time I typed the command, it said so it has to make sure that there is a space between POF and -I. So now if you notice, it's basically recording data packets being sent or received on that particular interface. So now I'm going to open up my browser, because in passive fingerprinting you don't actively send any data packets to the victim. Let me just open up my browser and connect to the victim's website. So maybe the victim is imt.edu. So if you notice, the website address or the website has now been displayed. In the meantime, if you go back to POF, it is trying to basically record all the data packets you're receiving, and it is trying to analyze which operating system is running on the victim's computer. But in this case, if you notice, it's not able to detect the operating system. So it was not a successful kind of command. So like I had warned you earlier, passive fingerprinting does not always work. It doesn't have a 100% success rate. But this is what you need to essentially do. Oh, now if you notice, I actually spoke too soon. Because now if you notice, right at the bottom, let me actually copy paste what it's detecting. So if you look at this highlighted portion, it has basically been able to detect the operating system running on a Google/AOL server. It says it is running Linux 2.5, and sometimes it could be Linux 2.4 as well. So it was not 100% failure, or I don't think it was able to detect the operating system of imt.edu, but since in my browser I had also opened up Google before I opened up this IMT website, it was able to actually detect the operating system of the Google server. So try it out. It may or may not work, but essentially the way passive fingerprinting works is what I exactly just showed you. So that was the POF software. Just the way you have POF, you also have another software called Network Miner. So let me open up Network Miner on my computer. It will take a minute or so for it to open up. So if all of you look at the screen, this is what the Network Miner software looks like. Step number 1 is you need to select from this drop down menu option, you need to select the interface that you would like to start monitoring. So I'm going to select the Ethernet interface and I click on start. So now all communication that is going on that interface will start getting recorded. So let me open up imt.edu. So if you notice all these different interfaces it's contacting or recording. The interface is recording all the various websites that we are visiting. And you can click on any one of these log data entries to try and reveal the operating system that was detected. So if, say for example, this particular IP address, the operating system is Windows. And this happens to be a system within the Talent Edge network, because if you look at the TTL, the distance is 0, so it's essentially one hop away. So this is the Facebook server. So it was not able to detect the OS of the Facebook server. So you have to try each entry out and see what happens. Some of the entries it's able to detect the OS, while others it's not. So it's a pretty easy to use software. And you've got to keep running it for some time and keep interacting with the website, that the victim website, and try and find out the operating system of that victim. So say for example, it has detected some computer whose name is Vaibhavi PC or Kunal PC, and the operating system is Linux. That's probably a computer within the Talent Edge network. So it's a data sniffer that records all data packets being sent or received on your interface, and then analyzes the interface to try and figure out, or analyzes the data packets to try and figure out the operating system that is running on that particular computer. So let me go ahead and stop it. I think all of you get the whole idea behind network miner. So that's how you perform active fingerprinting and passive fingerprinting.